The law of conservation of mass. The law of conservation of mass states mass is neither created nor destroyed during a chemical reaction. In a chemical reaction, atoms are rearranged to make new products with new properties. A chemical reaction is when chemical bonds break and new bonds form. So let's go back and look at this picture. We have blue, red, orange, green, and blue. And then on the product side, the new product, we have all the same colors. Nothing has been taken out and nothing has been added. Chemical reactions are represented on paper by chemical equations. Chemical equations are a shorter, easier way to show chemical reactions because they use symbols instead of words. What you start with is called your reactants. What you end with are called the products. So think about when you bake a cake. You start with eggs, flour, sugar, butter, things like that. And then your finished product is the formed cake. So let's look at this chemical equation. We're going to break it down and dissect it and show you everything it stands for. In this chemical equation, we have coefficients and we have subscripts. Okay? What you start with are your reactants. What you end with are your products. This arrow in the middle represents yield. Okay? Remember I taught you the acronym RAP, R-A-P, reactants and products. Remember that. So reactants and products, the mass of the reactants must equal the mass of the products. So let's look at this chemical equation again. We have 3 grams of hydrogen gas, 1 gram of oxygen, and that's going to give us 4 grams of water. So 3 plus 1 is 4, and then we have a total of 4. What you start with, you must end with. So it's the same formula almost. Okay, so let's look at this. We have the chemical equation. Then we have the same chemical equation in picture form. Okay, so 2H2 plus O2 yields 2H2O. So let's look at the reactant side. Remember, the coefficient tells you how many molecules, okay? And there's 2 atoms of hydrogen here. So there's going to be 2 molecules of 2 hydrogens. Then we have a subscript of 2 on oxygen. So we have 2 oxygen atoms here. So we have a total of 4 hydrogens and 2 oxygens. On the product side, or the right side, this tells me I have 2 molecules of water. Okay, and water is H2O. So that's 2 hydrogens, 1 oxygen, 2 hydrogens, 1 oxygen. We add up our hydrogens, we have 4. We add up the oxygens, and we have 2. This equation is balanced, meaning that it follows the law of conservation of mass. Atoms were not created, and atoms were not destroyed. What we started with, we ended with. Okay? Same formula here. Now let's look at this formula. We're going to count the atoms, and if it's balanced, it follows the law of conservation of mass. If it's unbalanced, it does not. Okay, so here we have no number here on this carbon, so that gives us 1 carbon, and there isn't a coefficient. Hydrogen has a subscript of 4, so there's 4 hydrogens. And when there's a plus sign, it starts a new formula. So we have a subscript of 2 on oxygen here, so that's 2 oxygen atoms. On the right side, we have 1 carbon again, but we only have 2 hydrogens. The hydrogens are not equal. Oxygen on this side, there's 2 here, 1 here, so we add those together and we get 3. So this chemical equation is not balanced. Another example, there's 1 carbons on both sides, 4 hydrogens, but when we get to oxygen, there's only 2 on the left, but we have 4 on the right. So this chemical equation does not follow the law of conservation of mass. Now let's look at this one. 1 carbon, there's 4 hydrogens, and there's 4 oxygens. Remember the coefficient, 2 times 2, and we get 4. On the product or the right side, there's again 1 carbon. We look at our hydrogens here, there's 2 times 2, there's 4. Oxygen, there's 2 oxygens here. And remember the coefficient, you multiply by everything in that formula. So there's going to be 2 times 1, so there's going to be 2 more oxygens with a total of 4. Carbons are equal, hydrogens are equal, oxygens are equal. So this chemical equation is balanced and it follows the law of conservation of mass. Now let's look at an example word problem. It says, in the complete reaction of 22.99 grams of sodium with 45 grams of chlorine, what mass of sodium chloride is formed? So first I wrote this out in symbol form. I wrote my chemical equation out. Na is the symbol for sodium. There's a symbol for chlorine, and this is my sodium chloride. So the problem told me I had 22.99 grams of sodium and 45 grams of chlorine. How many grams of sodium chloride should I have? You're going to add the reactants to get the missing product. So 22.9 grams plus 45 grams yields 67.99 grams. So this is balanced because when I add this together, I get 67.99 and I also have 67.99 on the right. Okay? Here's a list of websites to help you if you need it. Remember to send me a message if you have any questions about this lesson.